हाँ सर, प्रोग्राम शुरू हुआ सर। हम्म, हाँ। हेलो। हाँ सर, बोलते हो। चलिए, चलिए।
Amit, I guess we can start now.
Definitely, madam.
Yeah.
We are 50 plus.
Yeah. I mean, it is just the thing that everyone should understand CF.
Right.
And I heard that in that region it's very cold, so it can give 5 minutes later to everyone. It can be accepted. Okay. So, good morning, everyone. Yesterday, we have started with illustration of CI and we have completed one learning attempt, right? So, today we will be continuing with learning attempt 2 and 3. We have to be a little bit faster in that so that we can actually start with coding of CI on MATLAB also. So, we need to understand the coding of CI. We need to understand the coding or the code for root level approach as well as the code for sphere function. Okay, so let me share my screen. Okay, so just a quick recap. Yesterday we have started to solve sphere function using cohort intelligence algorithm. Number of dimension we have taken as two. So number of dimension in case of CI is qualities of the candidates. So we have taken two variables x1 and x2. The global minimum for the CI is that f of x is equals to 0 for all the x values to be 0. We are looking forward for the minimization function. So we have to minimize the function having upper bound and lower bound as minus 5.12 to 5.12. So this is our search space. We have to reduce the search space in order to achieve the global optimum solution. It is a unimodal function. You can see here from the 3D plot that it is a unimodal function. Okay, we have started with first learning attempt having reduction factor, keeping reduction factor as zero point 0.9. These were the qualities for candidate 1, candidate 2, and candidate 3, and the qualities associated were x1 and x2. We have calculated the objective function, or we can say evaluated the objective function, calculated the probabilities by doing the probability calculation formula 1 upon f of xc1 for the candidate 1 divided by denominator we have calculated earlier, so that denominator can be useful for all the probability calculations. Then we have used the Rule-Level approach. We have opened the Rule-Level. We have marked the instances on the, you can say, Rule-Level scale. We have calculated the cumulative probability in order to understand that we are not doing any, I mean, we are not going wrong in any calculation part. So if cumulative probability comes out to be greater than 1, then definitely there is some calculation error. We need to correct that. Then we have assumed that some random numbers have been generated for every candidate, and depending on the region where that random number is falling, we have assumed the follow mechanism. Okay, or we have, you can say, we have presented a follow mechanism. So C1 follows C2, C2 follows C2 itself, and C3 follows C1. From that we have adopted the qualities of the candidates. So these qualities have been adopted, and then we have used the sampling interval reduction by doing the multiplication by reduction factor, and then making new original and new upper and lower bounds. And then we have again calculated the new ranges or new upper bound and lower bound for every quality of each variable. And then what we have done, we have formed a new matrix of updated sampling intervals. Any doubt till this point? Any doubt till this point?
No, ma'am.
Okay, so now what we have to do is we will be starting with learning attempt 2. Now in learning attempt 2, these are the updated sampling intervals, and from this updated sampling range for every variable we have taken one random number. Okay, or we can say that we have generated the associated qualities. So from this sampling range, the associated qualities generated are these. Again, as I told you yesterday also, that you can select any random number from within that range. Okay, right now, for understanding that if we all are on the same page, please take these values as random numbers for or qualities for learning attempt 2, and please go ahead with objective function calculation and probability calculation. I'm waiting for the answers. Yes, what are the answers for objective functions for candidate 1, 2, and 3? Have you got the same answers? And what are the answers for probability calculation?
Ma'am, PC1 value is and 368.
0.68.
368. 1.49 divided by 4.08.
Anyone else with the answer so that we can cross check if this is something wrong or what?
It is supposed to become as 0.28, ma'am.
Means 0.28 is
Yes,
right?
0.028.
Okay, Professor, I guess there is some error in the calculation. Could you please cross check?
Check it. 1.49.
Denominator is 4.08.
08. Yes. Maybe.
No, no, no. You have to do 1 upon 1. Because of that, the answer is coming wrong.
Yes, yes, yes. Oh, right, right.
1 divided by 1.49.
Yes, yes.
So, I guess that could be the error.
Denominator is 2.37 only.
Hmm. Right, Amit. Thank you. Okay, anyone else with the probability values? Just cross check the probability values, please. If you are done with the calculations and if you are getting the same results, then at least raise your hand so that we can go ahead. Okay. Thank you, Dr. Bhavna. So let's go ahead. So then Rule will for this probabilities 0 to 0.2826, 0.2826 plus 0.2492, so 0.5318 and 0.5318 plus 0.4680. This comes out to be 1. So our cumulative probability is coming correct. Any doubt till this point? Now, yesterday someone asked me, I guess two or three faculties have asked me question that what if the same number is generated, right? That was the question that what if 0.66 is generated or what if 0.52 is generated, then candidate will follow which candidate? This was the question, right? So now, when we will write the code on MATLAB also, or you guys have also tried earlier, that these are approximation methods. Okay, so in approximation, if you even generate 1,000 random numbers in between 0 to 1, then you will not find a single random number which is duplicate of the other random number. So it is not even possible that the same random number will get generated. Are you getting my point? That these are the approximation techniques. So approximation techniques won't generate the same numbers or repeated numbers. Are you getting? When we will write the MATLAB code or in general also, you just try to generate the random numbers, maybe in Python or maybe in some other language. And if you generate 50 random numbers, you won't even find that the random numbers generated are same. So the question where whether the candidate will follow the C1 candidate or C2 candidate, this question won't be there if you generate the random numbers in approximation. Same number won't be generated. Okay, is the idea behind the random number is clear?
Right, madam?
Okay. Now, again, we have generated the three random numbers for C1 0.11, for C2 0.17, and for C3 0.45. 0.11 will fall in this category, so C1 follows C1. 0.17 falls again in the same category, so C2 follows C1, and 0.45 falls in this category, so C3 follows C2. From that, we have adopted the qualities. qualities are adopted from this matrix. Okay, so we have adopted the qualities. So C1 follows C1. Sorry, so C1 follows C1. So we are not changing the qualities, that C1 is following itself. C2 follows C1. So qualities of C1 have been adopted by C2, and C3 follows C2. So qualities here are written for C2. Now every time don't take the original range. Okay, we have already reduced the range to this point. Now apply the reduction factor on this range. Okay, so 9.216 multiplied by 0.9 is this much, and then divided by 2, so 4.14. This is your new upper bound and lower bound. Please complete till this point, and then add 4.14 to this and subtract 4.14 from this, and you will get new ranges for candidate C1, C2, and C3. Write this much and then calculate the range. I will show you the results and you can cross check. Okay, let us move on to the calculation for C1. So these are the new upper bound and lower bound for C1. Please cross check your answers.
Ma'am, for point 7,
Hmm.
the upper bound is 4.84 or 4.48?
0.7. 4 point, it should be 84, I guess.
Yes,
4.14 plus point 0.7.
I got that.
4.14 plus 0.7. Yeah, it should be 4.84.
Okay.
This is 4.84. Thank you. Thank you for correction. PC1, PC2, PC3. Okay.
Excuse me, ma'am.
Yeah.
Ma'am, in the second calculation, it was with minus one, so the range is 5.14, and you have round off it to minus 5.12.
Hmm.
So why it is not minus 4.14? I mean, we are considering the new range, na? Then
Hmm.
why we are going back to 5.12?
No, so see, this is a very good question, and I mean, this is one of the modification or one of the new thing which you can try while coding. Okay, so there are two things. You have rightly said that either you can go back to original range, okay, which is minus 5.12 and 5.12, or else you can go back to the new range. So that is also one of the option while doing the coding. Okay. Right now for illustration part, let's go back to the original range only. But I mean, while coding CA algorithm, I've started I guess in 2015. So when I have coded the algorithm for getting more better results and in you can say less computational time, I have tried this. What you are saying, that going back to new range, not going back to the original range. Okay, but it is not advisable for all the problems, because as I said in our previous lecture, that answers or the solutions for those functions which has global minimum as 0, for them this technique is useful. But if you have global minimum at 2 minus 3 or some other values, then in that case going back to original range is more beneficial, because if the algorithm is stuck somewhere for local optimum, then the jumping out of the local and finding the global is more easier in, or not easier you can say, is more preferable in case of going back to original range. Okay.
Yes, ma'am.
Yeah, so when I have written the code, in fact, for multi-CI also, I have kept two conditions, going back to original and going back to new. And I usually comment one of the criteria. I generally test algorithm with original. If it is not working, then testing it with new range. And either of them generally works. But thank you for this question. So I guess you have understood CI very well now. Okay, so these are the ranges. Here is the correction 4.84. So these are the new bounds for x1 and x2 of C1. C2 follows C1. So again, the calculation will be same because the qualities adopted are same. So for C1 and C2, we have the new ranges. Now let us go for C3.
Yes, ma'am, got the range.
Okay. So updated sampling intervals are these. Okay. This is here, it should be a corrected value 4.84. If you keep 4.48 also, answers won't come wrong. But as there is a calculation mistake, please correct it as 4.84. If you all are done till this point, okay, if you all are done till this point, then let me know so that we can go ahead. Yes, everyone, updated sampling intervals. Have you written the updated sampling intervals? Yes, have you written the updated sampling intervals?
Yes, ma'am.
Okay. I'll give one more minute if others have not completed. Please at least write these matrix so that, I mean, this matrix so that if you want to solve it later on, you can cross check the result. Okay. Now, third learning attempt. Again, we have to randomly select the numbers within this range. Okay. We have selected these random numbers and we have calculated the objective function values. Please do the calculations till this point and then let us observe the convergence plot. Once you are done with the calculations till objective function, please let me know.
Still, ma'am, your screen is not visible.
Sorry, I'll share the screen here. Okay. So, done till this point. Learning attempt 3. Everyone done till learning attempt 3?
Yes, ma'am.
Yeah. So now convergence plot. We have taken number of iterations on x-axis and number of value of objective function on y-axis. Okay. This blue line indicates candidate 1, this one is candidate 2, and this one is candidate 3. For the first learning attempt, candidate 2 and 3 objective function values were 5, and for candidate 1 objective function value was 1.25. So we have marked the candidates over here. After that, for second learning attempt, the values of the objective function for candidate 1 was 1.49, candidate 2 1.69, and candidate 3 0.9. And for objective function, for learning attempt 3, the objective function values are 1.21, 0.58, and zero point 0.4. If you can see here, the candidate 2 and 3 jumped from 5 to somewhere in the range of 2, 1, in between 1 to 2. Candidate 3 jumped from 5 to 0.9. Now, if you look at the candidate 1 and candidate 2, they have already started going towards the minimization 0.58, zero point 0.4. And we want answer as 0 for this peer function. Now, here candidate 2 का जो iteration 2 का solution था, that was much better than the solution of iteration 3. But this is how they learn. They become better, they become worse, again they will become better. In this case, candidate will try to follow candidate 2 or candidate 1 because they are doing much better than candidate 3. So this is how learning happens. Okay, and we call this as convergence plot. If you want to plot it, you can plot. If you want to observe it, you can observe. And if you have any questions, you can ask me. After 5 minutes, we will start with MATLAB coding. I mean, 5 minutes means maybe within 2-3 minutes. You just complete this. If you have any questions, if you want to just go back to illustration part, we can just, go back, and then we will start with the coding. Okay. So, should we start with MATLAB coding, or you have any question till this point? Should we start with MATLAB coding?
Yes, ma'am.
Okay. Okay. Is my screen visible?
Yes, ma'am.
Yes.
Okay. So, let's see here. We have started with initialization part. Lower bound is equals to minus 5.12. Upper bound is equals to 5.12. Number of candidates C is equals to 5. Number of variables 2. Reduction factor zero point 0.8. You can take zero point 0.9 also. It is not an issue. And maximum number of iterations right now I have kept 100. Depending on the R value, we can change the iterations to 100, 200, 300, and so on. Just give me a second. Okay. And then this counter for counter underscore runs is used when we are going to run the program multiple times. Okay. So if you want to run the program only once, then this counter is not needed. But as explained by Dr. Kulkarni in first and second lecture, that statistically significant value, that if you are saying that there is no free lunch in your algorithm, okay, so it should not happen that you are getting value by chance. Okay, so if we are talking about that, then we should solve the algorithm, or we should solve the problem 30 times, and we should check the standard deviation. Depending on the standard deviation, we can comment on the robustness of the algorithm. Okay, so here you can keep the value as 1 right now, as we are doing this for the first iteration, and then we can solve the algorithm 30 times and check. Okay, then we have generated the x values. X is equals to upper bound minus lower bound into random of c comma n plus lower bound. So this is a random number generation formula in MATLAB. So C is a number of candidates, comma number of variables. As I told you earlier, as I told you earlier, that we will check whether the random numbers are getting generated or not. We will check everything step by step, but let us first understand the code, at least till we call the function. Okay, then we have calculated the range. This will be your original range. Okay, because this range will be calculated earlier, before the counter for iteration starts. Okay, once the counter for iteration starts, these x values and this range won't come in picture again, because if we take this x again, then we are going back to the first iteration, and we don't want that. So we want updated values of range and updated values of x or qualities to be there in the next and next iteration. Okay, so if we run the code, I'll just show you. See, you can check here that the candidates are jumping and then we are getting the conversions. Okay, now just give me a second. Okay, now I have kept one breakpoint here and I have run the code. So if you want to check the values of x, then you can see here that we have generated 5 by 2 matrix and these are the values. Okay, so in our illustration example we have taken 3 candidates and 2 variables. Here we have taken 5 candidates and 2 variables. If you want me to change, I can change that also. And that's why keep all these things in the initialization part, so you can increase the number of variables from 2 to 10 or 2 to 30 also. So these are the x values. Okay, then we have calculated the range. So range is 10.24 as we have taken 0.9. So this is same as our calculation part. Okay, and then here we are calling the sphere function, that is summation of x square. Okay, so we have entered into the sphere function. Okay, and in sphere function it will take one variable, it will sum that, it will square that variable, it will sum that variable, and value will be stored in the y variable. Okay, so once we have stepped into sphere function, this is the sphere function. Now this function you can write in your own way also, that here I have kept it like a matrix. You can directly call the values. It all depends on your proficiency in coding. Okay, so no need to break the function in two variables. You can directly call the function for complete matrix, and then there are different different ways of writing a code, that it will take both the variables, it will do the summation and everything, and will get value. This is the easiest way that I have break the function. Like first I have kept s is equals to 0, then did the square part, then added it in s, then again s value is increased. But then it is not possible for every function, because functions are quite complex. So then in coding part you call the function in such a way that it will take all the values into consideration. Now if you check here also, then here the x is reflected correctly. This is what you need to check when you are doing the coding part, that whatever the values are assigned in the main program are the same values going into the sub program also. Okay, then once this step is done, this step will be completed 6 times. Okay, so I'll just step this out, and then we, what we have done here, so we have done the inverse of the matrix. Okay, why inverse of the matrix? Because for probability calculations we need 1 upon f of x, and for denominator also we need summation of 1 upon f of x for every candidate. So what I did is I have just simply taken the inverse of the matrix, and then what I have done is I have calculated the denominator. Okay, okay, tell me one thing, do you want to write the program with me? Have you opened the MATLAB? Do you guys want to write the program, or you just want to understand the program, what to do? Okay, tell me one thing. How many of you use MATLAB? Just raise your hand. How many of you use MATLAB? Right now, how many screens are open for MATLAB? There are 75, I mean, participants in this FDP, and there are only 4 people who are using MATLAB. What about others?
Some of the participants are joined through a Facebook also, madam.
Through?
Facebook Live.
Okay, okay. No, but through Facebook Live, they should not be able to join this meet, right?
Yeah, madam. They can join this Meet Live.
No, no, they can just check on Facebook. I mean, they should not
Okay.
look.
Yeah. So here is the limitations of 100 users,
No,
madam.
no, that is fine. I am asking like 78 participants are there. At least
Yeah.
10 are using MATLAB right
No,
now
no.
so that they can write the code with me. Otherwise, it will not be useful for others. And many of them are computer science and ENTC faculties, right? So if they are not writing the code with me, then I mean, so I'm just asking whether they are even present or not for the session. Okay, so no worries. At least 5, 6 people are using MATLAB. So Dr. Bhavna, Nikita, and I guess Prof. Raju, you can tell me if you are writing the code along with me, then I'll go a little bit slower so that you will also have the same code with you.
Ma'am, I'm not just using the MATLAB now. I'm
Okay.
at home, so
No, no,
I
that
don't
is
have
fine.
that.
I mean,
You
okay,
can proceed with the explanation of the program. It
Yeah.
will do. We are
okay,
understanding that.
okay, fine, fine, no issues.
Thank you. Thank you.
Okay. Then we have called a sphere function over here. So sphere function calling is done. Once we have received the objective function values, we have done the inverse of it, and then we have calculated the denominator part. After calculating the denominator part, we have calculated the probabilities by taking the inverse of every function and dividing it by denominator. So this is a probability calculation. Okay, once we are done with probability calculations, we have calculated the cumulative sum. So let us keep one filter over here and check the PC sum. And you can check here that probability calculation sum comes out to be 1. So our probability calculation or cumulative calculations are correct. Then new range calculation is done. So new range is calculated as 4.14 because we have multiplied the range with 0.9 and divided it with 2. So this is our new range. Okay. And then just check that whether the new range is going below 10 to the power minus 30. This is not that useful in the earlier iterations, but as we keep on doing things for maybe 50, 60, 100 iterations, then range will get reduced, and we need to check that it should not go beyond 10 to the power minus 30 or 10 to the power minus 20, because then that much smaller value is of no use for the range reduction. Okay? And then we have used a program for roulette wheel approach. I'll show you roulette wheel program also. So here roulette wheel program works on the probability and the number of candidates, and then it generates a random number for every candidate, and it checks on which I mean for which platform or the range the random number is generated, and according to that Roulette will give us indexing. I'll show you what type of indexing it will give us at the output. So let us keep one breakpoint over here. So here the Ruleville program is run for 3 times for different candidates, and check at the output. The value is 233. It means that candidate 1 is following candidate 2, candidate 2 is following candidate 3, and candidate 3 is following candidate 3 itself. Okay, so we have not generated random numbers or not have done anything. We have simply given the probability values to Ruleville, and Ruleville have generated the random numbers, calculated the I mean checked in which category it is falling, and it has given us the indexing. We have to use this indexing as a follow mechanism. Clear the row level approach? Clear with the row level selection? So these programs I'll share with you. Maybe right away also I can share if you want to. I mean, if you are doing it on your screen also, then it will be helpful for all of you. So this is the program for row level selection. Please remember that these PC and C, these are the what we call it as variables which we have used in the main program. So if you are writing anything else like probability or anything, then use the same variable over here. And in fact, I'll share the CI program with you also. Just give me a second. Amit, have you received everything in the chat box?
Yes, ma'am.
So till leader, this one is program for roulette wheel. This one is program for our main CI code, and one more call function also I need to share with you. Okay. Yeah. Now, if you are doing the program for ACLE function, or if you are doing the program for any other function, you need to check the upper bound and lower bound and change the values accordingly. And here simply call that function. So in place of sphere, you can write ACLE, you can write Grivon, you can write Rosenbrock, and save the program in the same folder as where all these programs are saved. So this is how we generally write. I mean, this is how a generalized program is written. So we just have to call the function, okay, and the program will remain same for all the functions. Okay. Now, here the new matrix is generated. This new matrix is what I will tell you. This new matrix is nothing but it has adopted the qualities. Okay, what we have said, if you look at the earlier matrix, this is the earlier matrix, and let me check the new matrix. Yeah. So if you look at the x values, then minus 2.6575 and 0.4833, these are for candidate 1. Okay, so candidate 1 को तो कोई फॉलो नहीं कर रहा है. वी हैव सीन 233. सो कैंडिडेट 2 की वैल्यूज है 1.3607 and minus 3.9051. Okay, so if you check here, then candidate 1 follows candidate 2. So values are candidate 2 key qualities. Candidate 2 follows candidate 3. So these are qualities for candidate 3. And candidate 3 also follows candidate 3 itself. So these are the values. So whatever we have written in the illustration, or whatever we have solved in the illustration, same thing we have implemented in the program. That's why illustrations are very important. And then what we have done is we have added the new range and we have subtracted the new range. This is what we have done. -1 new range, add key, new range, subtract key. From that we have generated these new upper bounds and new lower bounds for the candidates. So these are new upper bound and new lower bound for the candidates, and from that we have generated the new x values. So the new x values are these. Please make sure that whatever variable you are using at the start of initialization, same variable you have to use here. Otherwise, you will get new answer every time and you will don't understand that what happened. So x value initialization should be out of the loop of number of iterations. And this is the x which is overwritten every time at the completion of one iteration, second iteration, third iteration, and this is how range is reduced. Okay. After this, We have just checked the stopping criteria if number of iterations are complete, and then we have plotted the graph. And here we have saved all the function values. You can check this. I said yesterday that please save all the function values of every iteration, objective values. So this is how we are saving all the function values for every iteration. And then we are checking if the number of runs are completed. We are done. Okay. Now what we will do, we will clear all the breakpoints and I'll show you the graph first for 30 iterations only. Here you can check that these are the three different candidates, okay? And these candidates are somewhere on 22, 23. They are trying to jump on every iteration. And after some time, the learning is so good that they try to achieve the global optimum solution. And now you can see that all the candidates are on the same point. That's why we can't even differentiate the color. Okay, we will again run the program for more number of iterations, 50, and you can see the convergence. Okay, now look at the function values. These are the function values for candidate 1, candidate 2, and candidate 3 for every iteration. Okay, so you can see here, we were discussing about precision yesterday. Okay, so this is, this is what we talk about precision in 10 to the power minus 16. Because if you look here, we feel that value is 0, but value is actually not 0. It is 10 to the power minus 4. And we want precision to be minus 16. And that's why we increase the number of iterations. Okay, we increase the number of iterations. We have run the program again. Now the convergence is very clear. Can you see the plot also? Is the plot visible?
No.
No?
No, madam. No.
Oh my god, wait. So then I was just explaining. I am very sorry. I thought that MATLAB plot is also visible to you. Uh, okay, let us again change it to 31st. Is the plot visible now?
Yes, ma'am.
Okay, I'm very, very sorry. I have shared only one window rather than sharing entire screen because, okay, now I'll explain again. Very sorry. So you can see here that candidates are somewhere on these points 37, 21, 18. So from that, candidates are trying to jump towards 3, 1.29, then 0.98, and if you look here, then all the candidates are at 0.18. But still, this 0.18 we won't consider as 0 because we need high precision. Okay, so if you check at the value 30, then 0.08, still we don't consider it as 0. And this precision is of no use. What we will do, we will increase the number of iterations. Let us increase it to 100. Run it again. Okay, now check the value. It is 1.85 into 10 to the power minus 8. Okay, now if we talk about the function values, then you can check here the function values. And that's why we need all the function values to cross check whether all the candidates are getting convergence or only one candidate is doing very well and other candidates are still showing the maximization. Okay, but still these results are not that much appreciable. Let us change it to 200 first. Let us check whether the convergence, I mean the value is getting reduced or not, or we are just increasing the function evaluations and there is no point in, I mean the value is not changing at all. Let us check that. So from function, we can check that. And here you can see we have reached to e to the power minus 16 minus 17. And now this is the acceptable solution. Now the thing is, this is for one run. Okay. If you want, you can save this workspace. Okay. Simply save this workspace and again do the calculations, or what you can do is run this program for 2 times. I mean, we have to run the program for 30 times, but let us see what will happen if we run the program 2 times. These are the answers for run 1, run 2. Okay, I'll show you how to calculate the robustness also. Let us run the program 30 times. Let me check the function values. If you can see here, we are getting we are getting e to the power minus 16 somewhere around 174 175. So 200 iterations are okay. Now we are running the program 30 times. Because of plot, computational time always increases. So whenever you are calculating the computational time, comment on the plot section. Don't plot it, I mean don't take the plot every time for every run, otherwise your computational time will increase a lot. Okay. It will take little bit time, so we have to be patient. Okay, let us stop the program. Let us see where have we reached. Just wait for 2 3 minutes. Okay, so let us check for 10 runs. Okay, so for 10 runs, these are the values. Okay, I'll show you for 30 runs also. Let us comment on the plot section first. Because of this plot thing, the time required is too much, and we don't want that. Okay, and now let it run for 30 times. It will be much faster and Hmm. Okay. Now you can see here, these are the values for 30 runs. Okay. Take the values, put it in the Excel. Okay. And calculate the standard deviation. And if you look at the standard deviation, then the standard deviation, wait a second. Then standard deviation is 0.0000 and so on. What I want to convey through this is how we call the algorithm robust. It should not happen that we are getting solution for one run and we are not getting solution for other three runs. Then we can say or we can claim that we are getting solution by chance or we are getting answer by chance. But when we run the algorithm for statistically significant number, that is 30, and then when we take the standard deviation, okay, then that standard deviation talks much about the robustness, and this is how you can claim on the robustness part. Okay, so and here you can check the x values also when you note the answers. Then these are the final x values for which we are getting the answer. This is the new range for which we are getting the answers. This is the lower bound matrix, this is the upper bound matrix, and everything you can see here. Any questions in this? Any questions? Do you
Participant, if you have any questions.
Yeah. Ma'am, can we run it for another benchmark function?
yeah, definitely. I'll show you for Ackley function also. Just give me a second. I will show you Ackley function first. I'll show you what are the upper bounds and lower bounds for Ackley function. And yeah, one more thing is there. Okay, let us go first with the Ackley function. Just give me a second. I'll open the Ackley function part first. Okay. First, I'll show you the ACLE function. This is the ACLE function. Okay. You can refer this website also for other functions and their descriptions. I'll put it in the chat box. Okay. So for ACLE function, you can see that the upper bound and lower bound, these are the recommended variables. Okay. And the function is having upper bound and lower bound as this, minus 32.76, 32.76. You will get a MATLAB implementation code also. There are many other websites where you will get this MATLAB implementation code, or you can refer this website itself. That's not an issue. And the number of dimensions we can keep right now 2, we can increase it to 30 also. There is a ACLE code which I have already written in MIT FDP. So ACLE, can anyone see ACLE? Yeah, this is ACLE function. The name is, let me check the function, ACLE call. So we just have to copy it and write it in place of sphere call. Okay. And we will change the values to minus 32 point. Okay. Just a second. Screen hang over here. Just give me a second. Yeah, Amit, is the screen visible again?
Yes, ma'am.
Yeah, okay. Sorry, there is some network error. So we have taken minus 32 to 32. You can take that 32.76 also. That is not an issue. Reduction factor is. Let us first make the variable value as 1. Sorry, number of runs as 1. And let us try for 100 iterations first. Let us check whether there is any error or not. Okay. Line 52, there is an error. Okay, so in actually call, the number of variables considered are n, so there should not be any problem. Again, let us run the code equals to 2. Okay, and this error was there earlier also. Wait, this is, I mean, this error is of no use. It is just some folder or some corrections are there. Just give me a second. Okay, so function call error. This is not our function. This is just. Okay, let us close the.
Ma'am will join very soon. Accidentally, she closed the window.
Yeah, Amit, by mistake I have closed the complete window.
Yeah,
Sorry. Yeah,
yeah.
just a sec.
We know very well.
Yeah, I just came out of everything. Okay. That is just a MATLAB error. That is not a, I mean, programming error. Sometimes, I mean, while doing the continuous coding part, if the folder is changed or if the path is not connected, sometimes that error comes. Because now for sphere function also that error is coming. And I don't think so it is of any significance at least. Let's see. Oh my god. Let us change the values to the sphere function first. Okay. Amit, just give me a second.
Yes, ma'am. Apurva ma'am, I hope you are there.
Yes, Amit, I am there. There is some problem with MATLAB license. Because of that, the error is coming. Just give me 2-3 minutes. I'll get back to you.
Yeah, ma'am. I'm
Yeah.
waiting.
Okay. So now the problem is solved.
Participant, thanks for the patience.
Yeah, yeah, really thank you for the patience. So, what has happened? The error was showing that index is increasing the bounds. So, when the rule program was running, it was running only for one candidate. It was not even a MATLAB license error. So, all the three candidates were not stored, and that's why here, when the second candidate is coming in the loop, it was showing error that we don't have a previous matrix for the second candidate. Okay, now we want to see it for accolade function. So this accolade call, when I was copy pasting the program for your Windows screen, that time mistakenly one variable got deleted, and because of that, the error was coming. So I click all, and the bounds are minus 32 and 32. Okay, save the program and now run the program. Now you can see the behavior is totally different, but let us first analyze the values. So let us go for the function values, and the function values are 0.00, 0.00. Means we need to achieve a lot more for the 0. E to the power minus 16. So we'll increase the number of iterations to 200. Now the entire screen is visible, right? You can
Yes,
see the
the
plot
graph
of,
is visible now.
yeah, okay. Now if we check the value over here, okay, it will take time because it is a 200 iterations into 3 candidates. So see, it is 3.23 into 10 to the power minus 8. So now for accolade function, as the range is wide, minus 32 to 32, we were getting e to the power minus 16 for sphere function at 200 iteration. Okay, but for accolade function, this is not the case. So what we can do is, now let us check what effect it will cause if we reduce the reduction factor. Okay. So you can see the program is running quite faster also. And let us check the values for function. And now for 200 iteration, we are getting minus 16. Again, I'll show you if we are making it 0.95, run the program. So you can see the jumping from the highest value towards lowest value has got increased because the range reduction is increased. Okay, and if we look at the values of the functions, then at 200 iteration we have just reached 0.00. Okay, now if we reduce it, let us make it zero point 0.6. The convergence is quite early, started at 10th or 15th iteration itself. Okay, you can see here in the graph
Yes.
that convergence started somewhere here only. See, okay, and if we look at the function values, then we have got the, I mean, zero value e to the power minus 16 somewhere around 75 itself. If you reduce the reduction factor to 0.3,
Maybe might earlier only.
then convergence is at sixth or seventh iteration itself. Okay, and if we look at the function values, then we have raised to e to the power minus 16 somewhere on 45th iteration only. But we call it as early convergence, and we generally don't go for early convergence. Okay, so we can keep the R value a little bit on the higher side. We can keep the number of iterations somewhere where we can reach the maximum evaluation. Okay, and then from that we can observe the graphs. So in this program you can simply change the lower bound and upper bound values, and here change the call function, and depending on that you can evaluate the different functions also. Only thing is, if you go into these functions, try to see that these are little bit modified according to very basic I mean, those who have very basic knowledge of programming, for them we have made the function like this. If you want to use the functions which are available online directly, then make changes in the program such a way that here you can call the complete x value as it is from the matrix. So first candidate 1 ka x1 and x2 should be called, then x2 and x1 and x2 for candidate 2 should be called, something like that. Okay. Okay, any question? Any question about the evaluation or any question about the illustration or coding? Yes, any question?
Participant.
I guess there is no question. Okay.
Ma'am, can you suggest some problems on which we can do, I mean, apart from this benchmark functions?
See, Dr. Bhavna, there are 75 benchmark functions. Okay, so if you want to make your code robust, then first go for at least 50 benchmark functions. Okay, those 50 benchmark functions you can find in my paper, or I'll give you my paper also with the study material. So first you try those functions. Okay, once you are done with those functions, then Dr. Bhavna, may I ask you, are you from which domain?
Ma'am, I'm from Electronics and Instrumentation
Okay,
Engineering.
so like for electronics, you can go for VLSI design problems. Okay, for floor planning problems. So there are this AMI 33 type of problems which are generally dealing in floor planning. Then, like for manufacturing domain, I have solved abrasive water jet machining and electro discharge machining type of problems, which are somewhat related to instrumentation. Also, you can go for those type of problems also. So once you are, I mean, a little bit okay with the programming of CI, at least you are confident that the code is running very well, then you can go for these real world problems. You can find everything on our OAT lab website. I'll share that link also. Just give me a time. OAT research lab. So I have posted the link in the chat box. Please check. On this OAT Research Lab, you can find the different problems, codes, and codes related to specific problems also which we have solved. You can find our, I mean, different papers and different books also. And if you want anything from that, if you want any reference material for that, you can simply email us and we will provide you. And
Thank
ma'am,
you.
are you from which college?
Ma'am, I'm from D.Y. Patel University, Navi Mumbai.
Navi Mumbai. Okay. So whenever you want to visit MITWQ, you are most welcome. You can come here. You can sit in our research lab, and I mean, then one-on-one discussions can also happen. So we are always ready to, I mean, help in all the research aspects. Okay.
Thank you, ma'am.
Yeah. Thank you. And one more thing, I will share two more links with. Just give me a second. I'll share two more links with you. So there is one YouTube channel known as Think Bank. It is a Marathi channel, and where they take new topics into consideration, and they take, you can say, interview type of question answer session with the author. So here is the video of Think Bank. Two links are there. I'll share one more link with you. So Dr. Kulkarni have given interview on this channel, and this is a basic of AI in Marathi. Okay, so you can just go through these links if you want to show or if you want to explain it to I mean anyone in Marathi or any basics of AI. So then you can go through these two links. Have you received the links?
Yes, madam.
Yeah. And books related to our I mean this AI in Marathi. That link also I'll share in the study material. So if you want to order that book, maybe for your parents or maybe for I mean kids who have just started, or like parents are very curious that what we are doing in AI nowadays. So 24 to 25 applications are explained in that book, right from smart cities, garbage management, jewelry making, everything is there. So those links also we will share with you. Two things I would like to just tell you before I mean ending this FDP, that the conference which we have already told you, you all are most welcome to submit your papers for that conference. And the conference is definitely a Scopus conference, and proceedings will be published in Springer. So, if you want any detail regarding that, you can contact us. The conference link I will share with you right away. And if you have student papers, Purnima ma'am, you are on mute. Purnima ma'am, you are on mute. I am not able to hear you.
Shailesh sir,
Madam,
can you let her know? Shailesh sir, can you let her know about the same?
No, actually, I guess Purnima ma'am have joined without the audio, and that's why she's not able to unmute herself. Maybe you can log off and log in again, ma'am, or you can type your question in the chat box.
She,
okay, okay. I will convey the message.
yes.
Yeah. So the conference link is shared in the chat box. One more thing is there, that as we are a research institute, Institute of Artificial Intelligence, we provide internships to students also. We have couple of interns working with us in every semester. So like if your students are interested in working in the field of AI, if you want you and your group of I mean BTech or MTech students to work in the field of AI, then you are most welcome for the internship opportunities. But it is a type of full-time internship, so at least 2 months students should be here with us. It is unpaid internship, not a paid internship. But I mean couple of our students from BTech and MTech have published very good SCI papers with us during the internship time. So that opportunity is also there, as many faculties are from other institutes than JIT and college from Pusad. If you want this type of programs, any research methodology, research foundation related programs, technical paper writing programs, then we are happy to I mean share the knowledge base which we have with your faculties, with your MTech PhD students as well. And I mean we have couple of FTP every month here in MIT also. So maybe Amit can circulate the database with us, so we can keep you updated about these type of research workshops. We generally have AI for all also in the month of November or October, where we call elite peoples. If you don't submit anything in the conference, but if you still want to attend the conference, if you want to see what all is there in the conference, then you are most welcome for that also. So, Amit, I will provide you complete material maybe by end of the day,
Yes, ma'am.
and you can circulate it with the faculties. And if faculties have any question related to anything, the platform is open.
All the participants are requested to give any questions.
So, Suruchi ma'am, you can write to me on my email, and I'll definitely get back to you for any queries or any help related to research. Thank you, thank you. Amit, when are we going to start with the valedictory
Just
function?
in a 10 minutes, ma'am.
Okay, okay. So I need to communicate with Dr. Kulkarni. Okay.
Yes, ma'am. No
Yeah.
issues.
So any question, or maybe I can take break of 5 minutes and we'll come back for valedictory
Yeah,
function.
sure, ma'am.
Yeah. So no questions.
Participant, if you have any questions, uh, we are going to start with in next 10 minutes. We are starting with the valedictory function.
But what is the scope in image processing?
Yeah. So we have one Springer authored book for optimization models in steganography using meta heuristics. So one of professors from our group, she was working on image processing and steganography model and using CI only. Right now, I am working with one of the professors from computer science. We are working on GAN models and GAN charts for this recognition of letters by removing the lines. So we are working on Marathi, Hindi, and I guess Bengali data for the language set. So definitely in image processing domain we have, and one more student last month he completed his internship for recognizing, I mean for analyzing the blood cells and analyzing the data from the blood cells related to what diseases or what I mean problems a person is facing. So these type of many other things are there which are related to image processing in which we work, and there is a lot lot of much scope in the field of image processing also.
Thank you, ma'am. Thank you.
Okay. Okay, Amit, so I am here only. Okay, Neha Tirupure, ma'am, please advise if the institute keeps any material for study or reference for continued access on any open port. Yeah, so Miss Neha, I mean, we have this OAT Research Lab website which I have shown you. Let me share my screen. I'll show all of you that website. So, can you see the screen? Yeah, on this website,
Yes, ma'am.
you can see MATLAB codes for like this is for my book, the lectures which we have given. You can simply copy paste the code and code will run. Okay, so and everything is free of cost. Okay, there is no running fees or anything. So these are the codes which are available. This is about cohort intelligence, which we have talked. These are the 3D plots and different graphical representations and illustrations. This is the CI code also. These are different functions. You can check Grivong, Rosenbrock, Spear. So these are the functions which are available. Okay. Then you can check ideology algorithm is also there. So everything about ideology algorithm is given. So we have this platform um, where you can simply log in and check everything. You have our email ID with you. You email us and we will reply you within, I mean, whatever the time permits us, but we will definitely get back to you And right, what I said, that if you want that these type of things should be should be taken as a lecture series, because we follow that practice also. Like we have done the FDPs for foundations of research, then scope of research, then research methodology, where we take actual examples. Like if you have a group of 10 faculties who are interested for FDP, then we can take research question, and we can see how to form a hypothesis, how to go ahead with that also. So these type of models we follow generally, in order to basically help students, faculties, and everyone to go ahead in the research. uh, Whether the scope of the conference is bounded to the theme intelligent systems for smart cities. So I'll open the conference link also. It is not it is The theme is smart cities, intelligent systems for smart cities. But if you go into the uh, detail of the theme, then you can see here that we have supply chain and logistics, social media, healthcare, cyber security and crime prevention, homes and structures, banking and finance, disaster management. And if you go into for authors, and if you check the special issues also, then in issues like special sessions. So if you go into the special session, this is proposed by me and Dr. Eva Deshmukh from NIT College, Nagpur. So here you can check that almost everything from biomedical instrumentation and healthcare is covered. Okay, so scope is for smart cities, but not limited to. So you can definitely submit your paper. We can go through your paper. We can suggest certain modifications also, so that it can get a related structure for smart cities also. So you all are most welcome to submit your papers. It is a very elite conference. Last year also we did this conference, and as we don't wanted to make it a generalized one, we are in the process of making a theme based, so that every year we can come up with some new theme. One more question is there. Thanks, ma'am. All sessions. Okay. It's really helpful to do. Oh, thank you. Thank you so much, Prajakta. Yes, ma'am. Okay, thank you. So, this is what a kind of request or suggestion, that those who are really interested to work in this domain, you can keep working. You can I have started with this basic coding of CI in 2015. I am also from electronics background, but it really helps to go forward in the research. Because of this, I have a good H index, good Google Scholar citations also. So if you keep on doing good work, everything will get into your profile. You don't have to run for citations, you don't have to run for H index also. Those who are from Nagpur, in this FDP, I will be in Nagpur for from I guess 28th to 31st for some personal family function. But if you are there, some group is there who actually want to work in this field, so then maybe I can spare 2 3 hours for those people. We can meet in person, and it can the research can be taken ahead, because one FDP will not suffice the purpose. It can trigger you, but it can open the huge domain for all of you. But if you want to continue it, then maybe that sort of things can also be taken care. So just let your coordinators or everyone know. And for other colleges also, if you want that your people should uh, advantage of these type of FTPs, then just write to me on my email, then we will see how to take it ahead. And definitely for students, this platform is always open. Institute of AI, we have a good research environment in our institute. 5 to 6 students can sit with us for research. So if your students want to go for internship, then both ways free of cost. We will not pay them, and we don't ask for any money from them. So they are most welcome for research over here also. Okay, thank you. So Amit, just give me 3 4 minutes break, and I'll get back to you
Yes,
for
ma'am. No issues. No issues.
just 3 4 minutes. Yeah.
Yes. We are supposed to start at 12.
Yes, yes, no issues.
Yes. So participant, in next 5 minutes we will start with the valedictory. Please be patient for the next 5 minutes. We just wanted to see few higher authorities to join. Yes, Nishant. Check लिया. क्या क्या? कब मिलते हैं? ब्रेक यानी कौन से ब्रेक के बाद? आप आए नहीं अभी तक.
गुड मॉर्निंग.
आलू इथून चाललो होतो वर आलू सोडून म्हटलं चला दर्शन घेऊन घ्या.
बिलकुल बिलकुल काहीच टेन्शन नाही.
कशा
बस ना चालू आहे.
हाँ सर, बोलिए. हाँ. कब तक कॉल वेट कर देखेंगे. व्हाट्सएप ग्रुप में डाला है. पर्सनल व्हाट्सएप प्रिंसिपल सर को पर्सनल भी किया हुआ है, मेल पे भी किया हुआ है. Yeah, thank you Kalyani madam, Prajakta ma'am, for your wonderful wishes.
Yeah, thank you so much. And those who actually want to work totally in the optimization, so we generally take 5 days FDPs on optimization techniques also. So basics of optimization, different methods for optimization, and then whatever we have studied, CI, PSO, GA, then their actual implementations also. So on OIT Research Lab, we will find all these 3 days, 5 days, and now as we have done this for these colleges, we can manage the timings and all depending on the faculty's availability, because you all are very busy with some other NAC and NBA work also. So we can manage the timings and these type of things.
We are waiting to join our principal sir.
Okay, no problem, Amit. Dr. Kulkarni will also join maybe in 2-3 minutes.
Yes, ma'am.
Very nicely organized program, Amit. I must say, flawless. Every day timing and everything is very perfect, and all the participants are. I mean, I really. This is, I guess, after many years we have done this type of program where all the participants are joining every day.
Yes. Thank
So
you
I
very
mean,
much, ma'am.
we felt really good that we are actually giving knowledge to those participants who are already interested and they actually want to do something better in that area.
Yeah, nice to.
So, I mean, every
We are
day the
glad to see.
functioning and everything was so flawless that I have never, felt like it is an online FDP. It was like I have to be on time to start the FDP, and almost 2 hours have gone like anything. I mean, every day we have to stop that. Okay, now 2 hours are over.
Yes,
Like, yeah.
I'm glad to hear you, ma'am.
No, no, very. I mean, from both the colleges, conveners, and whatever you guys are managing, it's really appreciable. Yeah. Good morning, Dr. Bhavani.
Hello, Apurva
Hello.
madam, how are
Yeah,
you?
I am fine, sir. How about you?
I'm very fine here.
Yeah, yeah.
I'm very happy to see you in this program.
Yeah, yeah, no, I'm glad that you have given us opportunity. So those who don't know, Prof. Bhavne used to teach me at the time of diploma in 2004 to 2007. So I really felt very good that whatever knowledge he disseminated at that time, now I'm able to give back something to society.
Yes, sorry for the interruption.
No, no, it's okay.
So Apurva, we will require definitely your help
Yeah, yeah, sir.
after this FDP also,
Yes,
because
yes, sir.
it's a very interesting and much needed area.
Yeah, yeah, sir.
I will
Sure.
your services after also.
Yeah, yeah, yeah. Because
I'm very happy to see you here as a
yeah,
resource person.
thank you so much, sir. Same here, same here.
Yeah.
So we have already suggested this to Prof. Mahajan also, that we will take series of these type of FDPs maybe every 2 months or so. In fact, if we want, we can arrange a offline FDP also that way, because I can travel to Nagpur that way. That is not an issue. So then we can find out actually group who is really interested in going further. So then this way we can continue it as a lecture series also, and for your PG students also.
Sure, ma'am.
Yeah,
Yeah, Dr. Kulkarni is also joined.
yeah, he joined.
Shailendra sir. Shailendra sir.
Yes, sir. Yes, sir.
Yeah. Can you hand over and Purnima madam is there.
Yes, she is.
So shall I hand over the system to Purnima madam?
Yes, sir.
Yes.
So the system is hand over to Purnima madam. Purnima madam, you can take over.
Okay, okay,
Dr.
sir. Okay. Thank you,
Kulkarni
sir.
is there.
Thank you.
Yes, ma'am.
Am I audible?
Yes, ma'am.
Yes,
You
ma'am.
are
Hello.
very much
Just a
audible.
minute.
Should I start, sir?
Yes, ma'am.
Yes, yes, ma'am.
Thank you, sir.
Ma'am, please, 2 minutes.
Okay.
Amit, do we have any link for this session also? A
Yes, ma'am.
live link,
Yes,
YouTube
ma'am.
or Facebook?
Yes, ma'am.
Can you just post it in the chat box so that we can?
Yes, madam, you can start, madam.
Okay, sir. Okay. I hope all the dignitaries are joined with us. Okay. So, namaskar and warm greetings to you all connected over here. To improve the golden moment of opportunity and catch the good that is in our reach is the great art of life. So, on behalf of the institution, Babasaheb Naik College of Engineering, Pusat, I am Professor P. Niranjani, delighted to offer a gracious welcome to you all in the valedictory ceremony of one week faculty development program on AI-based nature-inspired optimization method during 9 January to 14 January 2023, organized by JIT Nagpur and Babasaheb Naik College of Engineering, Pusat, in collaboration with Institute of Artificial Intelligence, Dr. Vishwanath Karad, MIT World Peace University, Pune. I request our resource persons, Dr. Anand Kulkarni sir and Apurva Shastri ma'am, to accept the seat of chief guest for today's function. Please, ma'am. Please, sir. Kulkarni sir. Respected Kulkarni sir.
Yeah, I'm here. Sorry. Yeah.
Thank you, sir. Thank you for.
Sir is traveling.
Okay.
Yeah. Actually, my mother wanted me to see her, so I'm going to my hometown.
Okay. No problem, sir. Thank you very much.
I'm here. Yes, I'm here. Yeah.
Thank you, sir. Thank you. To bless this function, we have with us Mr. Pramod Pampatwar, Director Technical, JIT Nagpur, Dr. Narendra Bhavane sir, Principal, JIT Nagpur, Dr. Avinash Wankhede, Principal, BNCOE Pusat. A warm welcome to you all, sir. So, many participants from different states like Punjab, Telangana, Delhi, Manipur, Tamil Nadu, Maharashtra, Mizoram, Rajasthan are benefited in this FDP. So, among all these participants, many of you are a resource person, many of you are very senior, but yes, we together enjoyed and learning, we was learning and enjoying all the session delivered by the eminent resource person, respected Dr. Anand Kulkarni sir and Apurva Shastri ma'am. So now it's a time we want to listen to the feedback of some of our participants. So I request our dear participant, please turn on your mic and share your valuable feedback with us one by one. So let us listen to the feedback.
Participants are requested.
Yes.
Dr. Namita.
So I request so please turn on your mic and you can share your views.
Hello.
Okay. Dr. Namita Parathi ma'am is on the line. So welcome ma'am. You can share your views.
Yeah, good afternoon everyone. This is Dr. Namita Parathi from Telangana, MVSR Engineering College, Telangana, Hyderabad. Hello.
Yes, ma'am. We are able to
hear
you, ma'am.
Okay, so it has been an honor to be very delightful for attending this FDP. On behalf of all the participants who has gained the knowledge in this FDP, I would like to extend my heartful gratitude towards the management and organizers of FDP for giving us the opportunity to attend this AI-based, nature-inspired, optimized method FDP for 5 days. How this 5 days has gone, really, it was like not online, we are working offline. So that interaction and communication between all of you was wonderful. And I think it has not happened in one day or one night. The wheel started rolling months in advance. So it is the hard work of the team, the management of BNCOE CSE department, and the faculties of JIT also. So I want to thank these all people. And finally, the speakers were wonderful, Dr. Anand sir and Dr. Apuva ma'am. We enjoyed your session, literally enjoyed the knowledgeable sessions. We didn't feel like it was a boring or sleepy or something like that, but it was interactive and very happy to attend the session. Thank you for the management of BNCOE. You are my family. Miss you all. So just want to thank. Okay. Bye, madam. Niranjani, madam, to you.
Okay, bye. Thank you, ma'am, for your kind response.
Dr. Namita and Dr. Yogesh are also in the queue. So, Dr. Namita, you can continue.
I welcome you, sir. I welcome you. You can share your views.
Hello.
Yes, sir. Raju, sir,
Yes.
you can.
Yeah. Yes. I'm Dr. Raju Bhivani from the Parent Institute, Baba Saheb Naik College of Engineering, Gujarat, working as head of the Department of Electronics and Electrical Department. We are at the conclusion of this FDP. Really, I appreciate the organizers for organizing such an excellent FDP. The faculty, excuse me, the faculty for the FDP, Dr. Anand Kulkarni and Dr. Apurva Shastri are very knowledgeable persons and have explained every point very nicely and very clearly. Thanks for the practical MATLAB session that was implemented all the things and whatever concepts were taught, that was clear when we had that session. Thank you very much, ma'am. I feel it is a very good topic for research also. I intend to try to implement this in image processing for my research candidates who are working under me. Thank you, Dr. Kulkarni and Dr. Shastri. Lastly, I would say that most of us are the faculty, almost I think, and we prefer to talk only rather than listening. We are weak listeners. So the best thing, what I feel, that is the highlight of this, is that lectures for 2 hours per day. And that was the optimized solution, I suppose. Right? And I congratulate all the organizations and the active participants for being the part of this FDP. At last, I will say that the in Marathi I will say FDP attend करून आम्हाला अपूर्व आनंद झाले. Thank you very much, sir. Thanks to the organizer for giving me the opportunity to express my feedback. Thank you very much. Thank you, sir.
Thank you so much, sir, for sharing your views. Thank you so much.
Dr. Yogesh Gollar.
Yes, sir. Do I audible?
Welcome, sir.
Yes, sir.
Yes, sir. Clearly.
Good morning, everyone. Sorry, it's now afternoon, so good afternoon, everyone. Myself, Dr. Yogesh Gollar from Political College of Engineering. I would like to thank the management, the organizers, and the experts for giving us such an delightful platform to listen to all the AIs and all everything, because now we have the AI emerging branches coming up in the market. So this FDP will surely help us. And Apurva, we would like to have a connect with you with your what you have said that you have research areas to work in. So I have some students working with that lineup.
Sure.
So please share your contact details so we can be in contact with you soon. Thank you very much. And Amit sir, thank you for giving me an opportunity to share my feedback. Thank you, sir.
Thank you very much, sir.
Thank you, sir. It's really a very good experience, a very motivating experience, we can say, when we listen to participants like you. Thank you so much.
Dr. Gumaste, sir is there.
Yeah.
Welcome, sir.
Yes, ma'am. Thank you. Honorable President, Mr. Jay Naik, and other trustees of Janta Shikshan Prasarak Mandal BNCOE Pusat, respected Principal Dr. Avinash Wankade, sir, Advisor of the FDP, Dr. Salim Amdani, sir, Convener and Head of the Department, Dr. Asole, sir, Coordinator and my friend, Professor S.P. Khandare, sir, FDP team of BNCOE Pusat, Director JIT, Pramod Pampatwar, sir, and my colleague, my senior, Dr. Bhavane, sir, JIT Principal Nagpur, and experts Dr. Anand Kulkarni and Dr. Apurva Shastri, ma'am, WPU Pune, and all delegates. In fact, just now I saw that Dr. Kulkarni is moving. So, traveling condition, it shows his participation. It itself is a mirror. How the Kulkarni doctor or even Shastri ma'am are ready to share their knowledge to the society. Experts started the session from basic concepts, what I observed, and explained the topics with rich of examples, mathematical formulations, problems and even graphical representations. It is a very difficult task as far as my experience is concerned. Of all the concepts they are covered, in that I felt very happy or even satisfied in the more satisfied in the swarm optimization, lower bound and upper bound topics, where some of my difficulties have been even cleared. I'm thankful to the experts and the staff of BNCOE and JIT team, FDP team for systematic and well organization of this FDP. Even after a long gap of COVID, it is very difficult for us to come back immediately and cope up with the timings. Really, it is a wonderful organization. Thank you one and all. Thank you very much.
Thank you, sir. Thank you so much. Participant like you really boost the confidence of whole team, sir. Thank you once again.
Any other participant would like to share their feedback?
Myself, Dr. Archana Kollu. I'm from PCCOR College, Pune.
Welcome, ma'am.
Yeah, thank you so much, organizing team and management, especially Amit, my good friend and colleague. It's great pleasure, and my research area being this optimization algorithms. I've worked on Jaya algorithm, Firefly algorithm, many algorithms. Thank you for the experts. Really, you have taken the journey was very smooth, and explaining the topics of convergence rate, parameter tuning, and then the exploration part. That is really challenging, and you have taken these topics very detail, and it was excellent session and short sessions, as sir has told, optimized way. 2 hours is definitely sufficient to get the things into the brain. Thank you very much. It was a good session all this week. It was a very good learning experience. Thank you so much.
Thank you, ma'am. Thank you so much.
Thank you, ma'am.
Any other participant want to share their views? Okay. Should I proceed?
If there are many comments in the chat box, we can proceed.
Okay. Okay, so we are very much thankful to our participant for your feedback. So your meticulous response and feedbacks really boost us, motivate us to organize and improve such events in future. So gratitude is the fairest blossom which springs from the soul. So as we come to the end of our valedictory session, on behalf of BNCOE Pusad and JIT Nagpur, I, Ms. P.B. Niranjani, here to propose the vote of thanks. I express my deepest gratitude toward the resource persons, respected Dr. Anand Kulkarni, Professor and Associate Director, Dr. Apurva Shastri, Research Assistant Professor, Institute of Artificial Intelligence, MIT World Peace University, Pune. They had given all possible best knowledge from this FDP by focusing on recent trends in artificial intelligence-based optimization methods with hands-on session. We expect the same cooperation and association from MIT World Peace University, Pune in future also. I am very much thankful to our Honorable President, Shri Jaibhav Naik, JSPM Pusad, and all JSPM directors for their kind cooperation and support. I am also thankful to all Board of Directors, JIT Nagpur, for kind cooperation and support. I am also grateful to respected Dr. Avinash Wankhede sir, Principal Babasaheb Naik College of Engineering, Pusad, and Dr. Narendra Bhavane sir, Principal JIT Nagpur, for their valuable time and continuous guidance throughout the FDP. So this FDP could not be possible without respected Dr. Salim Amdani sir, Advisor, BNCOE Pusad. Thank you for your cooperation, sir. I thanks to Dr. S.S. Asole, Convener and Head, Babasaheb Naik College of Engineering, Pusad, Professor Mona Mulchandani and Professor Mahadev Mahajan, Convener and Head, JIT Nagpur. I thanks to FDP Coordinator, Professor S.D. Khandare sir, BNCOE Pusad, and Professor Anil Bavaskar and Professor Amit Pimpalkar, JIT Nagpur for conducting this successful event. I thank to all committee members, CDC members, Dr. Sohel Boha sir, Dean R&D and all deans, HODs, teaching and supporting staff for their support. Thanks to all those who have helped directly or indirectly for successful conduction of this FDP. Lastly, but not least, I am very much delighted from participants for their patience during the FDP. So thank you all participants. The end of the story is the new beginning for many others. So on this note, I conclude this remarkable, memorable and knowledgeable valedictory session. So thank you all.
I would like to add before everybody signs off. I believe
sure,
I believe Dr. Shastri might have spoken about it, but this is really honor for me because I started my journey after my bachelor's of engineering. That I would like to be a PhD and I would like to give back to the society. So this is the time I'm giving back, and many thanks. You gave me this opportunity, and I hope I have made it little contribution there. But we will not stop here. Whatever we can go ahead together. I'm there for everything. I must thank what Prof. Raju has mentioned in Marathi, that Apurva Anand. So Apurva is my research baby. So but she's like my little sister. So we will go all together, and wherever we require, wherever we are required, we are there. So many thanks, and this is really an honorable moment for me and Dr. Shastri as well. So thank you very much.
Thank you, sir. Thank you.
Thank you, sir.
Thank you, sir. Thank you, sir.
Amit, your contribution is very much appreciated. Giving 2 hours every day, full attention is not a joke.
Thank you very much. It's my pleasure.
Thanks.
Okay. So, okay. So now I request all the... Yes?
Yeah, in fact, today when I was explaining illustration of CI for some time, I just forgot that all are faculties. When there was no response so I was like, why there is no response? Then I just remember I'm not teaching to students, I'm not in classroom. And then finally I was like, okay, there are 94 faculties who are like HODs and like heads of many other departments and schools. But then still, like what I said, that in online mode also every day, 85-90% attendance is really overwhelming for us. That's why everyday sessions are really more and more enhanced and challenging for us also, because every day there were questions, there were discussions from many of the faculties. So it was really helpful for me also to enhance my knowledge in this field. So thank you so much.
Yeah. Thank you very much, ma'am.
Thank you, ma'am.
Really appreciate it.
Okay. So now I request all the participants to turn on your camera for group photo. Please turn on your cameras for group photo.
Okay, ma'am.
So thank you all. So we are signing off for now. Thank you all for participation. Have a wonderful day.
Yes, ma'am. Thank you.
Okay.
Yeah.
So, Amit sir, any suggestion as far as the participant is concerned? Amit sir?
They were very fantastic, sir. They were joining.
No. Today.
They are till 12. It's
Sir,
very nice to
what?
see the participation.
So I guess there is one exam tomorrow. Mr.
Yes.
Shailesh is talking about that.
Yes.
So I have set the question paper, but it is not difficult at all. So I mean, you all can complete that exam. I mean, very easily.
Yes.
Just think many times before clicking on the right answer.
Okay. MCQ
But
based.
I'm also there in teaching field from 8-10 years, so I know from where participants can find the answers. So their questions are not there on the site. But if you have attended the FDP, if you read the question twice, you will be able to answer the question. That is not an issue. Amit, do share all the feedback and snaps with us also.
Yes, sure, ma'am.
Okay.
And I have shared every day's links on our LinkedIn page of MIT-WPU Institute of AI. So I have tagged JIT and other colleges over there.
Yeah, I have seen,
You
ma'am,
can
that.
follow, yeah, you can follow our page and share the link with others also for the updates.
Yeah, I will share all
Okay.
the links of the recording links with you also.
Yeah. Fine. Okay. Thank you so much.
Yeah.
Okay.
Thank you
Thank you.
very much,
Thank you. Thank you.
participants.
Thank you.
Thank you.
Thank you.
Tomorrow you will be having an examination. We will share the links in your WhatsApp group.
Okay.
Okay.
Okay. Thank you, Shailesh sir.
Oh, okay, sir. Okay, sir. Thank you.
Thank you, Bura sir, Amit sir.
Thank you very much.